Hello, today I'll be showing you how to set up a Raspberry Pi for network use as a network attached storage device using Samba. First off, we're going to have to start by downloading the Imager program that allows us to write to the micro SD card that is used for the boot device of the Raspberry Pi. So first we're going to download it for Windows. Click that, download, and then once you load that, we're going to open the Imager .exe. It should open the program for us. It's gonna give me a UAC prompt on Windows here for me to open. Great. It's just gonna have us install there. I just hit install, and now we're gonna hit finish. And here it gives us the option to choose an operating system and then choose the SD card in which we want to write to. So first we're going to choose the operating system, and we're going to choose Raspberry Pi OS, which is also known as Raspbian. I'm going to go under other and get the light version because I'm not going to really need a GUI for this, because why run a GUI when in all reality it's just running as a file management server. I don't have any reason to really interface with it in any other way, especially since all computers that are going to be making use of it are going to be connecting to it remotely anyways. Anywho, now that that's out of the way, we're going to choose our SD card. I have quite a few disks on here. I know it's this 16 gigabyte drive here mounted on H and I, which it's just going to unmount the two devices and essentially format the device to be one partition. Well, two partitions technically, because that's how the Raspberry Pi writes out the drive. So we're going to use that, right? It says all existing data on the mass storage device USB will be erased. Are you sure you want to continue? Yes, we'll do that. And essentially, it's going to write to the disk here real quick. I could have shown you how to format it within Windows beforehand, but since this program is smart enough to do all that for me, I didn't worry with that. I'll probably speed up the video here, and it'll just run through its course. So here it says that it has successfully written to the SD card there, and now it's just verifying. I do recommend you complete the verification just to make sure everything has been written to the card correctly. Otherwise, you could cancel this if you're in a hurry, but just for verification purposes, I'm going to let this run through and do its thing just to ensure that the disk was written to correctly. All right, and here we go. It says that it has successfully written Raspberry Pi OS to the USB storage device or SD card. So we can now remove the card safely. I will do that. And now we can close out of the program, and that should be it for this part of the recording. Next, you'll want to take that SD card and insert it into the bottom of the Raspberry Pi into that micro SD slot with the pins facing up towards the device. So I forgot that SSH needs to be enabled manually, so I'm going to log in as Pi, which is the default login. The password is Raspberry, so Raspberry, and enter. All right, now we're in. And now the default way to configure this easily is to do raspi-config, so raspi config, enter. Right, we gotta run it as sudo, so use it as the superuser do, raspi config, boom, and then we're in this prompt, which should allow us to set up our interfacing options. So it looks like we're going to interface through SSH, so I'm going to go over here and enable it. So enter. The default and weak passwords are security risk when SSH is enabled. Yes, that's fine. Okay. And while we're in here, if you want to change some stuff, we can change the localization so that it uses English, or the United States English, as the main entry here. So we're going to take away the British English and enable EN-US, which should be in here somewhere, and then UTF-8, EN-US, it's got to be in here, it's somewhere close. EN-US UTF-8, there, we'll
get rid of that and take out Great Britain's, because the Raspberry Pi is from Great Britain. And we'll go over here, we'll hit tab, and OK to complete. And I use space to toggle the entry. Okay. Many packages and Debian use localize to dismiss text in the correct order. So we're going to use enus utf8. So boom, let's set it as that. It's going to regenerate the localize. I don't know how you pronounce that. So it's going to redo a bunch of the file system and management stuff so that it uses the English US format. And is there any other things I need to do in here? I believe for the most part that's it. I'm pretty sure my network should give it the correct time. Yeah, that should be it. So we're gonna just go tab, finish. And now I should be able to interface with the device from the remote console. I'm gonna be using Putty as SSH. So let's close this session.
All right, now that we have enabled SSH on the device itself, I should be able to interface with it remotely. So I'm back here on my Windows box, and we're going to make use of a program called Putty. Essentially what it does is just allows me to interface with SSH super easily with the device. So the host name of the device, which can be dynamically found through the network, is going to be Raspberry Pi. And it should be running on port 22. Otherwise, I could use its direct IP address, which I remember was 10.10.100.195. So essentially, we log in. So the default user is Pi on the Raspberry Pi, and the default password is Raspberry. Gotta make sure I spell it right. Boom, and we are in. Look at that. So first things first, it's not secure to have the default password, especially if we're putting on all our private files with the network area storage device, or network attached storage device, technically. So we're going to do PASSD, or WD, to change the password. Current password, which is Raspberry. And the next part is going to be a secret. Perfect. So the password has been updated successfully. And from there, I have at least added some sort of security to the device. Next up, we got to install the updates for a repository. So I'm going to start by doing a sudo apt get update. That'll update the repository and make it so that I can install packages. I'm going to let this run through it real quick. Perfect. All right, so now that that's done, we're going to do a sudo apt. Actually, you don't have to do the apt get anymore. That is actually technically the old way. You can just do apt now, and then we'll do an upgrade. So sudo apt upgrade. And it looks like there's 10.7 megabytes of additional disk space that will be used. That's fine. We'll install that. Alrighty, and now that has completed the installation of the updates. So continuing on here, I need to set up the Samba share. So we're going to do a sudo apt install Samba and Samba common-bin for the binaries. And it's going to install all of those here real quick. So that appears to be 101 megabytes of additional disk space. That's going to be installing right to the micro SD of the card. That's fine. Yes. And we're going to speed right through this in the video again too. All right. So here it says it's asking whether or not our computer gets a IP address dynamically, which it does. It's from DHCP because I just plugged it into the Ethernet port and it just found it automatically. We're just going to say yes to use the Win settings from DHCP. All right, perfect. And now we've successfully installed Samba onto the device. So in order to continue on here, I am going to have to make sure that the hard drive in which I'm working with is actually formatted correctly. So I'm just going to do lsblk, which should list all the block devices. So here we have my 12.8 terabyte drive, which is actually a 14 terabyte drive, but because Linux reads file size slightly different from Windows, it's going to show up as 12.8 here. I see that it has not been mounted yet, so what I'm going to have to do here is mount the device here. Now, okay, so it turns out you need to reboot the PC after you do the sudo apt upgrade, because otherwise your mod probe modules do not update and you cannot mount NTFS partitions off the stock image. So now hopefully this should work because we're running a new kernel. So what you got to do is we're going to, instead of mount the drive, we got to actually put a file system on there. So what I'm going to do is sudo fdisk for /dev/sda just to get the whole device. We're going to m for help. We want to print the partition table that's on there. So we're going to do p. Currently, there is a partition on SDA1. And it has a type of PowerPC prep boot. Don't worry about that. That's because that's just the only one that allows me to write the NTFS file system to it. I'll show you how to do that. So we're going to delete the partitions. If there was more partitions on there, it would ask you to enter a number as to which partition you would like to delete, and then you hit enter and you continue to hit D until you'd like to delete those partitions. Then now we want to create a new label, so we're going to make it a GPT partition because one, that's the new interface, and two, we want to, because this is 14 terabytes, it's only going to work that way. So we're going to initialize a GPT disk. It's going to make its new GUID, and we are going to add a new partition. So in we are going to do 1 as the primary first partition. We're going to use the first sector all the way to the end sector. NTFS, it's going to overwrite it with Linux file system. That's fine. We'll say yes, because we're just going to rewrite it to the disk anyways. And then we want to go change the type of partition. So we're going to go T, L to list. Now there's all sorts of different types of partitions you can use. Goes all the way through these. Through my research, in order for me to write NTFS, I have to use 7 for PowerPC prep boot. So we're going to hit Q to end that, and we are going to type in 7 for the disk type. Now that that is done, we are going to write the disk. So that was W for write table to disk and exit. So W, perfect. Now, if I do a lsblk, we got that new disk. All right, so now that we have finally put this disk together with that partition type, and I can now do mkfs.ntfs to write a NTFS file system to that. I'm going to do -F for it to do it faster, quickly, and without writing the whole disk with zeros. And I'm going to select that actual partition. So /dev/sda1, enter. Boom, right, it's read only, so I gotta do sudo make file system ntfs-f and that partition. Boom. Cluster size has been automatically set to 4096. Perfect. Now it's going to create the NTFS volumes structures. All right. And perfect. It has created the NTFS file structures. All right. So now I need to mount that device here. So if we do lsblk, it was SDA1, remember? So we're going to have to make a directory we want to mount it to. So I'm going to do mkdir for make directory in /mnt/disk1. Granted, I've already made this location before while testing, so it's already there, but it'll create the directory if it's not already there. Then in order to mount this device, we're going to do mount, so mount /dev/sda1, because it's that first partition we're mounting. And then we're going to do /mnt disk1. Boom. Only root can do that. That's fine. We'll run it as root. So sudo. And very shortly here, it should mount that disk. So it looks like it mounted. So if we do lsblk, perfect. It's been mounted to /mount disk1. Now, if I wanted to, I'm just going to do something. I'm going to go cd/mnt/disk1. Just for testing purposes, we're going to make a file. So we're going to touch test text.txt. Boom. And then we're going to go nano testtext.exe just to edit it. And we're going to go, here is that file you created before installing Samba. Save it, Control S, Control X, perfect. So now there's going to be a file on that hard drive. If we look, it should be there. Test text is there. So perfect. Now it's a matter of actually setting up the Samba share itself. So earlier we installed Samba with the sudo apt-get install Samba and samba.com binaries or bin. So now that we've made that directory, I'm going to do sudo nano /etc/samba/smb config or conf. So that's going to bring us the config file. I'm going to just go all the way down to the bottom. Nope, I guess, oh, page down. That'll do it the fastest. So now I need to create a share. So now I'm just going to call it home share. And from there, it's going to have a path of equal to /mnt/mount/disk1. And from there, we're going to make the disk writable. So we'll say writable is equal to yes. And from there, we want to say create a mask, which is equal to 0777. This essentially is just giving us read and write accessibility. And then directory mask is equal to 077. So that's in Linux, that's pretty much just gives us read, write, and execute permissions. And then we're going to make it public, and that's going to be equal to no. And then if everything in here is correct, I should be able to hit Control S to save and Control X to exit. All right, I'm going to go back into that Samba config there, and instead of making it not public, I will make it public. So let's just do this. Home share is equal to public, and then say yes, and fix my formatting. Control save, Control exit. Now I'm actually gonna have to restart the SMB share. So sudo systemctl restart smbd and go boom. Hopefully that'll restart. Now granted, I already know what the host name is. It's literally showing there, but if we wanted to, we can go host name -i. That shows my IP address if I need a direct IP address, but I should be able to just dynamically resolve it as that. So we're gonna use this here, /raspberry pi /home share. And there we go. It's a Samba share. We got it. Here's that file you created before installing Samba. We did it. Congratulations. Now, I'm sure you're wondering, now what if I wanted to add credentials to that? So if I sign in, I don't need to, or I'll need a password in order to get to those files. Well, I'm glad you asked. I'll show you how to do that here real quick. So we're going to go back into that one file. So sudo nano /etc/samba smb conf, right? We're going to go all the way to the end of the file here, and we're going to say public, and we're going to say no, that is not okay. Perfect. Save, Control exit. All right. And then in order to set up a Samba password, we need to do sudo smb passwd -a, and then do it for my user. So pi, boom. And then it's going to ask you for an SMB password. And then I'm going to go set a password. It's going to have me retype that password. Perfect. So now I added user pi to the Samba share, correct? So I believe I could have just entered any name there, but in this case, since it's the Raspberry Pi, we're going to use the Pi username. Now, if I go into Windows and I go here to the device, we're going to go Raspberry Pi, home share. It's going to prompt me for credentials. Isn't that neat, huh? So now I go Pi, enter that password. Okay. And then boom, I have access to this super secret Samba file. Here's that file you created before installing Samba. Awesome, right? Now I'm sure you're wondering, how do I map this device as a letter drive and see how much space is available on there? So what we're going to do is click on this PC, right click it, and go to map a network drive. We're going to assign a drive letter for it. Yeah, Z's fine for me. And then we're going to give it the //raspberry pi /home share. Reconnect it, sign in, connect using different credentials. And we're going to go finish. And now we got to sign in with those credentials that we set up for it. What did I do? Okay. Boom, and then we have that. And better yet, we have how much space is on that hard drive. And I can throw any files I want on there. Let's say I wanted to back up some sort of program files data. So let's just go %app data % on another screen. Boom. Let's say I wanted to update my OBS Studio settings or back up the config there. I can just go, well, actually, I'm using that program, so I'm not going to do that. But let's say I wanted to back up my screenshot files. I can just go, boom, copy it, and they're here. Just like that. The configuration file for my thing is there. Instantly, I'm just able to transfer stuff. It's a great time, and it shows me how much space is on there. Honestly, great. And the fact that the Raspberry Pi runs on so low of power is amazing. So yeah, thank you for watching my video. Bye-bye.